Hey everybody, part two, we're dealing with practical problems with area and perimeter. Part one, we talked about the two formulas that you're going to have to deal with here, rectangles and squares, and we find the area, its length times width. And then when we deal with triangles and finding the area there, we take the base, which is the bottom, and the height, which is vertically from top to bottom. We're multiplying those two, and then we got to remember to cut it in half. That's right. We're going to divide it by 2. So now we're going to take a look at some actual word problems. Usually when they say practical problems, that means word problems. So let's take a look. So before we get started, super quick reminder, remember perimeter, that is going to be what part of the shape? Around the outside. And area, same rectangle, that's going to be inside, filling up the inside. And remember, that's always going to be in square units. How many square blocks can we fill inside of that figure? All right, first question. Mr. Motter is making rectangular placemats that are 12 inches wide and 15 inches long. What is the least amount of ribbon he will need to create a Star Wars border around each placemat? So when we have a story problem like this, the first thing you want to do is identify some key pieces of information. So let's see what we have here. First of all, it says he's making I am making a rectangular placemat. So the best thing to do would be to draw our picture. So here we have our rectangular figure. What else does it say? It says it's 12 inches wide and 15 inches long. So let's go ahead and put those numbers in place. There we go. 15 inches, that's the long side. 12 inches is the wide side. What else do we see? Is least amount of revenue created Star Wars border around each placemat. Now around. Is that on the inside or the outside? Well, let's see. Around would be perimeter. That is around the outside. So here's R2-D2. He is traveling around the outside of the placemat, going around the border. So how do we find perimeter? That's pretty simple. We just add up the sides. So 15 plus 12. Some people like to just jump in and say, oh, 15 plus 12 is 27. But is that correct? No. When we find perimeter, remember, we have to add up all the sides. So in this rectangle, we've got 4 sides. And if I know the top is 15, the bottom is 15. The left is 12, the right is 12. So we have to add all the sides together. So when we have our 15 plus 12 plus 15 plus 12, we're going to add them all up, and it's just going to be 54 inches of border we'll need to go around that placemat. And especially thinking of around, don't forget, circle your answer. All right, perimeter is easy, but let's start looking at a different type of problem here. It says the kitchen is 20 feet long and 10 feet wide. How many square feet of flooring does Bob need to buy? Well, let's see here. First thing I like to do is draw a picture, but I'm not sure how to draw this picture. I see that it says 20 feet long and 10 feet wide. So I'm going to guess that that is a rectangle. So let's go ahead and put those measurements in. There's our 20 feet and our 10 feet. What else do I see in our problem? Anything stand out? Well, square feet. If you think back to when we talked earlier about the two things, perimeter and area, we said the area always has square units. So I'll bet you if I fill up the inside with squares, that's going to be area. This is an area problem. And to find the area of a rectangle, we're going to take length times the width. Well, what was the length? 20. And the width was 10. So we're going to multiply those two numbers together. This is mental math, stuff we did in class. 20 times 10 is going to give me 200 square feet. And we circle our final answer. All right, let's go to another problem. At the atrium in town, there's a triangular garden. Ooh, I already have an idea about this one. The height of the garden is 12.5 meters and the base is 50 and 1/4 meters. How many square feet does the gardener have to plant flowers? Man, I got a lot of things going on here that already started triggering some ideas. So let's draw a picture out here. It says a triangular garden. So I'm going to draw a triangle, good looking triangle. What else do we see in our problem? It says the height of the garden is 12.5 meters and the base is 50 1/4 meters. Well, I don't like to use those fractions, so I know that 1/4 is the same as 0.25. So I'm going to put my base in there first. There's 50.25 meters. Now the height, if you think back to video number 1, the part 1 of this this section, we talked about an equilateral or an equiangular triangle and how it's kind of tricky to see the height. And what we need to do is recognize from the base to the tippy top. So we're going to put a dashed line in like this. That's going to represent our height. And instead of 12.5, I'm going to put 12.5 meters. Okay, I get rid of those fractions. They don't work too well when you're working on the calculator here. Now, what am I going to do with this information? Let's see. There's got to be something else in the problem. How many? Oh, square feet. Square feet, just like in a rectangle. When we're dealing with square feet, we want to figure out how many square units fit inside this triangle. That's area. And remember, for a triangle, we're going to take the base times the height, and we're going to divide it by 2. We're going to divide it in half. So let's go ahead and plug some numbers into our formula. Let's see, our base is 50.25. Our height is 12.5, so we're going to multiply those guys together first. Woo! Look at that number. 628.125. Now, I guarantee on a test, you're going to see that number as one of your possible answers because they're going to think, I bet they won't remember to cut it in half. But we're going to do that right now. We're going to take the 628.125 divided by 2. 314.0625 square meters. That's what the SQM stands for, square meters. Oh, I just recognized that mistake in our problem. Oh, look up here. Look up here. It says how many square feet does it have? Ooh, what should that say? That should say square meters. Ooh. See? Always got to figure out what we're asking for. Last but not least, circle your final answer. So plugging numbers into a formula isn't too difficult. So I want to give you a challenge here, and we're going to work through this real quick. It says Bob now wants to place a triangular flower garden in the front of his house to increase curb appeal. That means to make it look nice when people are driving by. What could the dimensions of the garden be if he has a space of 12 square feet to work with? Ooh, this is tricky. So I know it's triangular. So I'm going to go ahead and put a triangle in there. But now they're asking for the dimensions. The dimensions would be the base and the height. We don't know that. But what do we know? We do know 12 square feet. So that's the answer. So when we figure out the area of a triangle, it's base times height divided by 2. But we don't know the base or the height. The only thing we know is the area. So let's go ahead and just plug this number in and see what it looks like. So the area they said was 12. The base times height we don't know, but we do know we're going to divide it by 2. This ends up being one of our algebraic problems where we're going to try to solve for a variable. What is the opposite of dividing by 2? Well, I can multiply times 2. But if I do that to one side, I have to multiply times 2 on the other side. So we can go ahead and do that. That's totally fine. Looking on the right, what happens when I multiply and divide times 2? They cancel out. Oh. And then on the left side, I have 2 times 12 is 24. So I'm going to be left with 24 equals base times height. Now, I'm not going to tell you what the answer is because there's multiple answers. But what could our base be? What could our height be? What two numbers could we multiply together to get 24? There's more than one answer. Okay, guys, to finish up part two, I have two questions here. First thing I want you to do is identify what they're asking for. Are they trying to find area? Are they trying to find perimeter? Look for some of those key words. The client wants 4 kitchen windows to be framed with a special molding. The windows are 22 by 24 inches. How many total inches of molding are needed for the kitchen windows? If I'm framing something, think about a picture frame. What part of the figure would that be? Is that perimeter or area? The homeowner is replacing a laminate countertop with granite. Bob purchased a slab of granite that is 18 square feet. If the slab is 6 feet long, how wide is it? Ooh. So I see square feet, so that tells me maybe it's area, maybe it's perimeter, but they're giving me length, but they don't know width. So I'm curious to see if you can figure those two guys out. All right, I'm going to have some other questions for you to mess around with in the folder. So please make sure you solve these two and see what you can do with the others. Good luck, and as always, go Dukes!